Hello, Honors Geometry students, and welcome to our last lesson of the year. And today we're going to talk about the probability of compound events. We are still hanging out in Learning Target 4A. It says I can describe events as subsets of a sample space and calculate probability. All right, so today we're specifically focusing in on the probability of compound events, and that is two or more things happening at the same time. And we can break this down into two different categories. We can talk about independent events and dependent events. Independent events do not rely on something else. Dependent events rely on something else. So if you think about independent events, it's flipping a coin and then flipping it again. So whatever happened the first flip doesn't impact what happens on the second flip. Think about a tray of 12 cookies. You have somebody comes and takes a cookie off that tray. Your choices are impacted based on whatever that first person took, because that whatever they took is no longer an option for you, and that's a dependent event. All right, so when we're talking about the probability of independent and dependent events, we have two different formulas happening in here. If we're talking about independent events, where the outcome of the first event does not affect the outcome of the second event, all we need to do is find the probability of the first event and multiply it by the probability of the second event. So the example here says rolling a 6 on a die and then rolling a 5. So rolling a 6, there's 1 6 out of 6 sides on that die. There's 1 5 out of 6 sides on that die. So 1 6 times 1 6, we have 1 out of 36. Okay. The second type is the probability of dependent events, where the outcome of the first event does affect the outcome of the second event. So we take the probability of that original event and multiply it by the probability of whatever happened next. So the example is, without replacing the first card, choosing an ace and then a king from the deck of cards. So like I talked about in the previous video, a deck of cards has 52 cards, and we have 2 through 10, jack, queen, king, ace. Each of those has four different cards. And then we have the 4 suits, hearts, diamonds, spades, and clubs. So if we want to first choose an ace, there are 4 aces out of 52. But then we're not going to put it back. Then we're going to take a king out of that deck of cards. Well, I took a card out, so if I took out an ace, there are now only 51 cards in that deck, and there are still 4 kings in that deck. In order to simplify this a little bit more, 4 out of 52, you might simplify and say, all right, 4 out of 52, that's the same thing as 1 out of 13. Makes it a little bit easier to multiply this fraction, and we don't have to simplify at the end. So 1 times 4 is 4, 13 times 51 is 663. So the probability of choosing an ace, then a king without putting it back in the deck is 4 out of 663. All right, so let's continue on. Okay, and example 1, we just did that in the previous section, so we'll move on ahead. All right, so example number 2 is talking about a bag of marbles. All right, so let's get some marbles cooking here. We have 3 red marbles. We have 2 green marbles, and we have 4 blue ones. 1, 2, 3, 4, all hanging out in the bag. We want to find the probability that 2 marbles drawn randomly from the bag are not replaced. We want to find the probability that both of the marbles are blue. All right, so the first time we might take a look and say, hey, there's 9 total marbles hanging out here. And the first time I pick it out, I want to get 2 blue ones. So there are 4 out of 9 of those. 4 out of 9 is my probability that the first one's blue. So now One of those is gone. Gone, gone, gone. No longer considered. So now the bag of marbles only has 8 in it. But since I've already picked out 1 blue marble, that leaves 3 left. All right, and so I'll multiply my numerators and denominators. 4 times 3 gives me 12. 9 times 8 gives me 72. Both the top and bottom are divisible by 12, so that simplifies to 1/6. So the probability that both the marbles are blue is 1 out of 6. And remember, if we're doing our blackboard formative, you would divide this out, get your decimal, and round to 2 places after the decimal. All right, cruising along, example number 3. George has 2 red socks and 2 white socks in the drawer. So sock number 1, sock number 2. Okay. Can make it red if you'd like, if that makes you happier. I don't know. Okay, and then we also have the white socks. Okay, so what's the probability of picking out a red sock and a white sock in that order if the first sock is not replaced? All right, so here is our sock drawer. We want to get a red sock first and then a white sock. So let's deal with red first. You will notice that there are 2 socks that are red out of my drawer of 4. Okay, I've taken that out, so that guy is gone. The second time I reach into the drawer, I want to pull out a white sock. There are 2 white socks in there, but there are 3 total socks. Okay, this is a dependent event because what happens the first time impacts what happens the second time. So I'm going to multiply numerators and denominators. 2 times 2 gives me 4. 4 times 3 gives me 12. And we simplify to 1/3. Okay, cruising along. Example 4 is a die is rolled and a penny is dropped. Find the probability of rolling a 2 and showing a tail. All right. So in this example, whatever happens with the dice has no impact on what's happening with that coin, so this is independent. Okay, so we're going to find the probability of the first guy and then probability of the second guy and multiply them together. So the probability of rolling a 2, there is 1 2 on the side of a die and 6 sides if we're talking about a standard 6-sided die. Okay, looking at the second choice, we want to show a tail. There is 1 tail on a coin out of 2 sides. Okay, 1/6 times 1/2 multiplied by numerators and my denominators. The probability of rolling a 2 and getting a tail is 1 out of 12. Okay, moving along. Mutually exclusive and inclusive events. Events that cannot occur at the same time are called mutually exclusive. Okay, they can't occur at the same time. So the probability of rolling a 2 and the probability of rolling a 3 at the same time with 1 roll of the die. If we want to go Venn diagram on here, probability of a 2, probability of a 3, those 2 things could never happen. So the probability of rolling a 2 and a 3 at the same time is going to be 0. 2 events that are not mutually exclusive are called inclusive, which means there might be something in common. So, for example, the probability of picking a king out of a deck of cards, the probability of picking a heart out of a deck of cards. This overlapping area that I'm showing in my Venn diagram would indicate the inclusivity of it, and that would be the king of hearts. Okay, so if I'm talking about what's the probability is picking out a heart or a king, I can't just add those together because they have something in common. So let's take a look. So if we're talking about the probability of mutually exclusive events, okay, the probability of A or B is the probability of A plus the probability of B. So the probability of rolling a 2 or a 3 on a die, okay? The probability of a 2 is 1 out of 6. The probability of a 3 is 1 out of 6. or 2 out of 6, which is 1/3. We add up those individual probabilities if they can't occur at the same time. The probability of inclusive events, we're going to find the probability of the first event plus the probability of the second event and subtract those two events happening at the same time. So kind of like subtracting this Venn diagram piece up above. So the probability of a king or a heart, we would add up the probability of getting a king, the probability of getting a heart, and then subtracting the king of hearts. So remember, there are 4 kings out of 52 in a deck of cards. There are 13 hearts in a deck, okay? Because remember, there's 4 suits, 52 divided by 4, 13 cards. There are 13 out of 52 hearts in a deck. And then in that deck of cards, there is 1 king of hearts. So I'm going to subtract 1 out of 52. Okay? Since I already have my common denominator, 4 plus 13 gives me 17, minus 1 is 16 out of 52, which is going to simplify to 8 out of 26, or 4 out of 13. Okay, cruising along. What is the probability of choosing a king or a queen from a deck of cards? Okay, king or a queen. You can't pick out a card that is king and queen at the same time, so this is going to be mutually exclusive. Okay, there are 4 out of 52 kings in a deck. There are 4 out of 52 queens in a deck, so we have 8 out of 52 cards, which simplifies to 2 out of 13. All right, cruising along. A bag contains, so we'll get my bag diagram going again. Okay, my bag has 2 red marbles. It has 1, 2, 3, 4, 5 blue marbles, and 7, 1, 2, 3, 4, 5, 6, 7 yellow marbles. Find the probability of each. Okay, so taking a look, probability of yellow or red. It is impossible to get a marble that is yellow and red at the same time. And if I take a look here, count them up, there are 14 total marbles in that bag. All right, so I'm picking out 1 marble. I want to know the probability that it is yellow or red. There are 7 yellow guys out of 14 total marbles. Since this is mutually exclusive, I'm going to add. Probability of a red marble is 2 out of 14. I have a common denominator, so 7 plus 2 gives me 9/14. Okay. Moving along, what's the probability of red or not yellow? Okay, well this one's kind of goofy. We might phrase this a little differently, but just it's going to give us a taste of what this would look like. All right, so let's start with the probability of red. Okay, we notice here there are 2 out of 14 red marbles there. Okay, then I'm going to add in the probability of not yellow. Well, there's 7 of these yellow marbles. So if I count up all of the other ones, there are 7 out of 14 other ones. But the ones they have in common are the red, so I would subtract my 2 out of 14. Like I said, because this would be the not yellow ones that also happen to be red. Like I said, this one's kind of goofy, but it's just giving us an idea of how this would work. Okay, so erase my little markings. Oh, I need to simplify here. 2/14 plus 7/14 minus 2/14 gives me 7/14, or 1/2. Okay, last but not least, probability of blue or red or yellow. All right, there are 5 out of 14 blue ones. There are 2 out of 14 red ones and 7 out of 14 yellow ones, which gives me 14 out of 14, or 1. So as long as I'm picking out a marble, I am guaranteed that in this particular set that it's going to be blue or red or yellow. All right, last one. Okay, last one. Okay, in a math class, 12 out of 15 girls are 14 years old, and 14 out of 17 boys are 14 years old. What is the probability of selecting a girl or a 14-year-old from this class? All right, so let's start by taking a look. All right, there are 15 girls in the class and 17 boys in the class. So altogether, there are 32 students in this class. That's the first thing that I'm going to keep track of. All right. So the probability that I select a girl out of the class is going to be 15 out of 32. Okay. The probability that I pick out a 14-year-old. Okay, a 14-year-old. 12 of the girls are 14. 14 out of the boys are 14. So altogether, that is 26 14-year-olds. So plus 26 out of 32. But then I need to subtract the likelihood that we have a 14-year-old that is also a girl. So that would be 12 of those girls out of 32. And then I add this all up. 15 out of 32 plus 26 out of 32 minus 12 over 32 gives me 29 out of 32 as my probability of selecting a girl or a 14-year-old from the class. All right, your homework is the worksheet that's located on Blackboard. You can either do it in Notability or in Class Kick, and you also have a 3-attempt formative on Blackboard. All right, this was our last lesson. Please let me know if you have any questions. I will see you online. Bye.